Okay, let's begin. Homework number 4 is available on Blackboard, and I have to warn you, this assignment is long. And it's not necessarily long because it'll take you a lot of time, it's just there's a lot of problems there. And we're going to be learning some tools using Excel, and you can solve problems really quickly with Excel. And so that's why I felt a little bit more freedom to give you more questions, is because you can solve some of these in just maybe 5 or 6 minutes. So they're pretty quick problems. But since there are so many of them, I'd encourage you to get an early start. And especially because there were a couple of problems that I pushed from homework 3 onto homework 4. Did everybody get that email from me announcing that the homework was going to be kind of shifted slightly? There were a couple of topics that we didn't cover in as much detail as I'd like before you have a homework due. I don't ever want you to work on a homework problem in this class and be completely clueless and never having seen anything related to it before. And so I moved the last couple of problems from homework 3 onto homework 4, and then that makes homework 4 even a little bit longer. So you've got less than a week for this assignment. So it's important that after today's class, you'll be able to solve those 2 that I moved. And so I'd encourage you to get started on that. And then with the spreadsheet stuff that we're going to be going over today, start looking at those computer-based problems as well. Any questions related to the announcements? In class last time, in class exercise number 9, we did do the question related to finding the unknown I value. Remember, we used goal seek for that one, and we were looking either with goal seek or with the rate function. What was the interest rate that brought balance? Balance meaning that there was economic equivalence between the inflows and the outflows. That if you moved all of the money to the same time frame, all of the future amounts, you took it to the present, then in and out were equal. That's what we did with finding the unknown I. I was the amount that made it all into balance. Finding the unknown N is how many years of a certain revenue stream would you need to bring equilibrium. And so problem 2 in the in-class exercise, if you have your paper from last time, please get that out so that you can copy a few things onto the page. This is the statement that we had in that problem. A contractor purchased equipment for $60,000, so that's P. P equals $60,000, and that's a cost. And it's going to be offset by future revenues. An income of $8,000 per year. So A is $8,000. What we need to know is, if the interest rate is 10% per year, so I is 0.10, then how many years until the investment breaks even? Okay, the first thing that I suggest you do, rather than just leaving it at what is A and what is P, but what is the ratio A to P? So A divided by P is going to be 8,000 divided by 60,000. And if you've got a calculator handy, what you'll find is that the fraction there is 0.1333. So that means that the ratio of the annual amount to the present amount is 0.13 if it's discounted at 10% interest. Now look at this table, the column, the A to P column. And if we go down, what we're looking for is which row is it that we can find 0.1333. So which row? It looks like it's too high, the ratio is too high, and now it's too low. So it's somewhere between, if we take this over, between 14 and 15. So that's meaningful, because what it suggests is that you'd need to have between 14 and 15 years of this income to cover your initial cost. So that's where you're going to break even in terms of recouping the initial expense. So 14 years wouldn't get you there. You still wouldn't have gotten enough money back after 14 payments. So the ratio was too big, 0.1357. And remember, we're looking for 0.1333. And then with the ratio being too small here, that means now you've got more than enough revenue to cover the initial cost. So we can do these break-even problems with the factor table. That's one way. Another way is with Excel. And I'm going to do a demonstration now that I'd just like you to watch. You don't necessarily have to follow along, and in fact it's maybe better if you don't, just because it's so easy to get distracted with the formulas if you're watching it and typing it in at the same time. But this method is recorded in the video, and we'll come back to it again in the future as well. So let me start up Excel, and what I'm going to do is solve this problem with a spreadsheet. And what we have is an interest rate that was given in the problem statement of 0.1. That's 10% interest. And then we're going to add some columns here. We're going to have year, amount, the PV of the amount, and then I'm going to add a new column that is you haven't seen from last time. It's called the cumulative PV of amount. And you'll see what that is in just a moment. But the first thing is, let's just translate the problem into a cash flow table. You've done cash flow diagrams before, and that's a really good way to understand a problem. If it's just a bunch of words in a paragraph, making a cash flow diagram, a sketch of it, sometimes will instantly give you the clue that you need on what to solve for and how to do it. Cash flow tables are another way. So let's just go through time and find out what's happening to our investment. So the amount is that we pay $60,000 and then we receive $8,000 every year for, we don't know when it terminates. We just want to know, when are we paying off that original investment. Okay, PV of amount, we're using the function that we saw last time, PV, and now it's asking for the rate, so I'll click in this location and press the F4 button to anchor the reference. NPER means how many years is the amount being discounted from the future to the present. I'm skipping over the payment field because any amount I put into the payment field, it's going to repeat n times. And I want to treat each one of these rows individually, like its own separate year. And so I'm going to put the amount into the field that Excel is calling FV. So each one of these rows is a single future value. And I'm putting the minus sign in because of what we talked about last time, where it kind of automatically flips the assignment of revenue and cost. And of course, I'll change the formatting to be a little bit less irritating there. All right, so it's saying 60,000 is 60,000, and if I drag this down, what we'll see is that if you discount these future amounts to the present, they get progressively and progressively less valuable. So who could summarize, why is this amount less than the year before it, and why does the PV keep getting smaller?
The interest is compounding per year.
Okay, the interest is compounding.
Yeah, so like year one, you have $8,000, but at year 7 you also make $8,000, but there's interest on every single year, so it makes it less.
You definitely have the right idea. The only thing that I'd say is that it's not so much that interest is compounding. Like that specific word compounding means that the amount is getting bigger. These amounts are getting smaller. And so the opposite direction, when we're moving money backwards in time, we call that discounting. And so the amount is discounted for more years. And so this $8,000 in year 7, it has to move 1, 2, 3, 4, 5, 6, 7 years to get to the present. And all of those years of discounting, each time we move it 1 year, it loses 10% of its value. And so when it moves from year 7 to year 6, you have a 10% reduction in value. And that keeps happening each year. And so the future revenues aren't worth as much today because of inflation. You know, expenses, amounts are going to be things are going to be more expensive in the future because money isn't worth as much in the future. So what we want to do now for the cumulative PV of amount, in year 0, it's just the first amount, negative 60,000. Now, in year 1, we have our initial cost, but we've also received some revenue. So I'm adding the cell above and the cell to the left. And what that means is that after 1 year of operation, it's not like you're $60,000 in the hole anymore. You've gotten some revenue, and so of your original $60,000 investment, you've gotten some profits to bring down how much you haven't yet recouped. So now you're only $52,000 in the hole after your first year of operation. And after 2 years, a little bit less. And these are all in the present basis. And that's why we're not just adding the actual 8,000, but we're adding the amounts in present value terms, because we want to know, like in today's terms, since we paid with the more valuable money now, we want to be sure that we discount the future amounts so that the dollars are kind of on an equal footing. So if I keep this trend going, what I'm looking for is, when does it cross over from negative numbers to positive numbers? How many years of operation does it require before we finally have broken even and earned enough revenue to justify the expense? And what that tells us is the same thing that it did when we were looking at the problem in terms of the factor table. That the factor ratio of 0.133 we're looking for, by the 15th year, you've now gotten enough revenue. And this shows you that after 15 years of operation, now you have $849 in excess profit. That means that you've covered the 10%, and now you're getting even more profit over time. This is a complicated idea, and we'll come back to it, but the main point I want to leave with you is that you can solve for the unknown n either with the factor method, or you can use the equation method and solve for n in the formula, or you can do it with a spreadsheet. Unknown n is just saying how many years of a certain amount is it required to bring equilibrium between the two. All right, so are there any questions on us concluding that in-class exercise number 9? All right, so remember what Excel does is it assumes that if you put in a positive amount, it's going to discharge a negative amount in that built-in PV function. And so if we want it to stay positive when it's a positive amount, we have to put the negative sign into the function. Keep that in mind when we're working on the problems today that's in our in-class exercise. And so here's the PV function, the interest rate, the number of periods, and then we put in 2 commas so that we can skip over the payment field and put each row into its own future value area. The interest rate should be expressed as a decimal rather than as a whole number, and so 5%, for example, is 0.05 rather than just the number 5. And is the number of periods. Use the double comma to skip over the payment field. And I'll give you a demo sometime of what happens if you don't skip over it. Your numbers really go out of whack. And the minus sign to override Excel's assumptions. All right, so this is a cash flow diagram that you probably wouldn't want to solve manually. There's a lot of things going here. We've got 16 years of operation. And what we want to find out is if we take all of these amounts to the present, what's the present value equivalent? You could do it by paper. You could do find P given F for each one of these. And that's actually what we are going to do with the spreadsheet. But it's less tedious when you do it with the spreadsheet than if you're doing it by hand. If you're doing find P given F over and over and over again, then that can be cumbersome. So let's try out Excel. Now, your process here is to translate the cash flow diagram into a cash flow table. Did everybody get a copy of the handout? Why do I have so many extra copies? I guess maybe some of your classmates aren't here today. Okay, translate the cash flow diagram into a cash flow table. And so set up a spreadsheet. And in your spreadsheet, it says in the handout to give it a couple of specific column titles. You're going to have a column that says year, a column that says amount, and another one that says PV of amount. And so you'll start by having like an interest rate at the top, and then you're going to have year, amount, and then PV of amount. And then it's in this third column, the PV of amount. You're going to use the PV function on the cash flow table. That I've been doing. Let me copy it over. Okay, so I've got the function that I'm going to just drag down through the entirety of the right column, PV of amount. So it's equals PV. For the reference to the interest rate, it's up here to the cell where I've typed in 0.07. The reference for the number of periods is whatever row we're on, because that's going to tell it how many periods it needs to move the money from the future to the present. So for instance, this $12,500 in year 5, it needs to move that 5 years, 1, 2, 3, 4, 5, before it can contribute to an amount at year 0. So N is just whichever row you're on for the year. And then I skip over the payment field with the double comma, because I don't want it to consider each one of these rows as a recurring payment. I want it to consider it as an individual future amount. So when you do that and execute, of course it'll be 0 for year 0, but then I can drag that down. You know, rather than dragging down, you can just double click at the box like this, and then it'll automatically continue that for as many rows as there's data adjacent to it on the left side. So this is what you should have so far. These amounts. Let me circulate around in case you've got any errors or questions. If the column is too narrow, you start getting all those pounds. That's an issue. So if you just double click, it'll make it as wide as it needs to be for whatever's the widest thing in that column. All right, so what we want to do now is add all these together, because what it's saying is if you're moving this 12,500 to year 0, it's worth 10,917. This 12,500, since it's further into the future, it's not worth as much in today's terms. We want to know the sum total of all of them. So I'm going to just add it up. I'm going to call this sum, and then equals sum, and then highlight the entire range of amounts. 78,260. So that is the present value of this cash flow. So like, what's the meaning of that? Well, if someone told you that you were going to get this over time or a single lump sum amount now, and if your applicable interest rate is 7%, then this is the amount that is the present value equivalent of these future revenues. So this sometimes comes up with the lottery. Have you ever heard that, lottery winners have the option of taking, I don't know, $2 million a year for 20 years, or a lump sum payment of like a smaller amount? It's not the same as if they take it all at once or if they take it over time. So here, what we're saying is if you discount the future amounts at 7%, then the sum total of the present value is 78,260. All right, so that's how you find the present value. And with Excel, there's always an easier way. And so let me show you how to use the NPV function. In Excel, the NPV function allows you to just put in an interest rate and then a range of values. And the only amounts that should go into the NPV function are amounts that are in the future. Don't put amounts that are already in the present. All right, so let's see if we can figure out how to use the NPV function. So here I'm going to be using the NPV function. And so that is equals NPV, parentheses, and it starts to give you clues. All right, so rate. Let's just click on the location where we have the interest rate. And normally we'd press the F4 button to anchor that reference, but in this case we don't need to, because we're not going to be repeating this function over and over again. We're just going to do it one time. So I won't bother to anchor the reference. So rate, and now a comma, and now it's asking for a list of values. So I'm just going to start clicking here at the top and scroll down through the list. Okay, now look at the range that I've selected. Did I miss an amount?
You skipped 0, which you said you were.
I skipped year 0, and that was intentional, because year 0 is already at the present. See, what Excel is doing is it's looking at not only the amount, but the order in which it appears. And it's assuming that the first amount it sees is in year 1, the second amount it sees in year 2, the third amount it sees is in year 3, and it's going to discount all of those amounts. But if I put in this 0, then it would stagger the cash flow diagram an extra year. And so I'm only putting in amounts that need the conversion. And this 0 doesn't need the conversion because it's already at the present. So I'm just going to do NPV like that, and it tells me 78,260. So it saves us from having to do this entire PV of amount column. So sometimes you'll need to do this PV of amount anyway. Sometimes you can just use the NPV function, but it's good to be aware of both tools, both approaches. Any concept questions on finding the present value of this complex cash flow diagram? I've taught this course a lot of times, and I can predict what the common mistakes are going to be because I've seen students make them over and over. And one of the most common mistakes that I see is students who include the entire cash flow into the NPV function. Let me show you what would happen if you did that. So if you did equals NPV, and we refer to this interest rate, and then we put all of the amounts, including the amount that's already in the present. That's the wrong amount, 73,000. And the reason why is it's assuming that you have 0 in year 1, 0 in year 2, 12,500 in year 3. So you've added kind of an extra year into the sequence of dates. And so that's why it's important that you only include the future amounts. And then if there is some amount at time 0, then you'd add it separately outside of the NPV function. And then you'd get the correct 78,260. Caps, bold, and underlined, and exclamation marks. So I'm falling all over myself to emphasize only include future values in the function. All right, there is an FV function. PV was present value. FV calculates the future value. So instead of discounting amounts to the present, what the FV function does is it compounds amounts into the future. A lot of the functionality is the same as the PV function. You need to put the interest rate as a decimal, N is the number of periods. We do the double comma thing to skip over the payment field for now, and you have to put the negative sign in to adjust for the assumption that Excel automatically makes. So, I mean, all of this is old news. But the tricky thing is what to use for N. It's different than what we did with the PV function. So this is the cash flow diagram on problem 2 in your in-class exercise. And what we're trying to do is we're trying to find out what's the future equivalent of this cash flow diagram in year 16. All right, so this $10,000 at time 0. How many years does it need to compound in order to get to year 16? How many years away is it? It's 16 years. So we could count 1, 2, 3, but it's 16 years. So it's going to be earning 8.5% interest every year for 16 years to get to year 16. And so we wouldn't use 0 in the FV function. We'd use some other N. And that's why in the column suggestions, what I've suggested, set this up in Excel very similar to what we did before, but have one column that's called year. The next column should be called years until year 16. And that's what you'll use for N. Don't use 0 if you need to compound it 16 years into the future. What you should do is you should have kind of a secondary time column, and that should be how many years there is minus N in that secondary time column. Okay, I'm going to do it on the screen if you want to check and see whether you were on the right track for this one. I'll just paste the diagram so that's an easy reference. What was the interest rate on this one? 8.5%?
Yeah.
Okay. For the years until year 16, I do equals 16 minus whatever year it is, and that way you don't have to type it in manually, because there's always an easier way. Okay, we have a cash flow table, how many years it's going to move. So this 10,000, it's not going to move 0 years to get to 16. It's going to move 16 years. So at NPER, I'm going to have to make reference to this secondary time column. So equals FV at 8.5% interest, 16 years, amount. I put the minus sign in there so it doesn't accidentally change the sign on me. I'll make sure that I have it on the right currency formatting. All right, now I can drag that down, and so I find each individual amount, how much it's worth in year 16. And so the amounts are bigger rather than smaller, because instead of discounting to the present, we're compounding to the future. So the amounts get larger, and then we want to know the total. So sum equals the sum of all of that, the pluses and the negatives. It's like receiving a single payment in year 16 of $38.20. So you can either experience this cash flow over time or take a single amount in year 16 of $38.20. And they're economically equivalent. So these are pretty easy, as you can see. Like, as soon as you translate it, the cash flow diagram into a cash flow table, then just popping the PV or the FV function in there is almost trivial, as long as you remember to skip over the payment field, you remember to put in the minus sign, remember to anchor your reference. For instance, if you don't anchor the reference to the interest rate, what is it going to look like when you drag that formula down? It's going to be bad. So if there's just like a weird pattern going on, double check the formula and see what it maybe is. And so maybe it's that you didn't anchor the reference. Let me show you what, question here?
What do you put in for the values for the FV function? Sorry, I missed that.
That's fine. So the first one we do the interest rate.
Right.
The second one I'm using the secondary time column.
Okay.
So for instance, that's how many years in the future it has to move. So that's what we're doing for the number of periods. Skip over the payment field, and then each one of these is treated like a single present value. Let me show you what would happen, just so that you know, like, when things go wrong, what it might look like. What if you forgot to skip over the payment field? What would it look like then? So if we didn't put in the double comma, and instead it's seeing this 10,000, what it thinks, if you put it in the payment field, is it thinks that there's 16 $10,000 payments. So you'll see what it returns there, $316,000. So that's not right. Like, a single 10,000 isn't going to be worth $316,000 in the future, not at 8.5% interest. It should only be worth $36,000, but if we put it in the wrong field, you're just going to see astronomical amounts. And so, like a single 11,500, it's saying is worth 288,000. That's because it thinks there's 14 of them. That's what it means to put something into the PMT field rather than in the FV field. All right. I really like using Excel for these financial calculations. It's almost more fun than doing it by hand, if that's even possible. All right. Well, let me just refresh the suggestion that you get an early start on homework 4. I mean, you could plow through a lot of it after today. You can make some really good, quick progress while it's fresh in your mind. I suggest save the file that you've worked on today. Put it on a jump drive or save it on your OneDrive so that when you're doing the homework, if you need to refresh your memory of what you did for a certain function, then it's available for you. And the other last thing I'll say is feel free to stop by during my office hours if you have a problem that you can't figure out. Like, I may be able to look at your spreadsheet in just a couple of seconds, find a mistake that maybe has been tripping you up for a long time. So don't hesitate. That's why I'm there. I love to, I really like this stuff. I really like Excel. So feel free to stop by if you have any trouble. I'll see you in class on Friday.